This video is on the objective solve linear trigonometric equations in tangent and cotangent. I think it should say or cotangent, but because some of these are going to be in tangent and some of them are going to be in cotangent, where you're seeing tangent to the first power or cotangent to the first power, but you're not going to see both in the same equation in this objective. And this is pretty similar to solving those linear trigonometric equations in sine or in cosine, where you get your trig function alone. Then what I'm going to do is I'm going to state the general solution, describe all the infinitely many solutions to the equation, and then we're going to find the solutions that are in the particular range that they want. So again, if you want to see more about this, how they're teaching you, click on more instruction, look at their notes, their examples, their videos. Hopefully those help you. Alright, so we're asked to solve the following equation for theta, but they only want the values of theta from 0 to 360 degrees, right? But including 0, you got the bracket, but not including 360, right, a parenthesis. Alright, so it's 3 times the cotangent of theta minus 8 equals negative 11. Right. So then I'm going to write this out, and we'll find all the solutions, and then I'm going to cut it down to just those solutions between 0 and 360. Right. So I have 3 times the cotangent of theta minus 8 equals negative 11. Alright, so just like your sine and cosine equations, I want to isolate the trig function, right? I want to get this cotangent of theta alone. So the first thing I would do is add 8 to both sides. Right, so now I have 3 times the cotangent of theta equals negative 3. And then we divide by negative 3 to isolate that cotangent function. So I have the cotangent of theta equals negative 1. Alright. So what I'm going to do next, there are infinitely many angles that have a cotangent of negative 1. So I'm going to state all those. Right? We're going to I'm going to describe all the infinitely many solutions to this equation. I'm going to write the general solution. But first, I'm going to think about just going around the unit circle once. Right? Just going around the unit circle. Imagine the unit circle. I'm not going to draw it. Right? Imagine going around the unit circle counterclockwise one time, and think what angles have a cotangent of negative 1. Now, if you don't remember your cotangent angles very well, hopefully you remember that cotangent is cosine divided by sine. So so basically, if the cotangent is negative 1, that means cosine divided by sine is negative 1. Or cosine and sine are opposite values. So one of those would be 135 degrees. All right, this is an angle in quadrant 2. The cosine would be negative square root of 2 over 2, and the sine would be positive square root of 2 over 2. They're opposite, so the cotangent would be negative 1. And then I could add, take 135 degrees, right, say there. Take 135 degrees, and I could then add 360 or subtract 360 and land in the same spot. So what I'm going to do here is I'm going to write out, I could then take this 135 and add on 360 degrees times, k, where k is an integer. Right, add on any integer multiple of 360 degrees, and I'd get another angle with a cotangent of negative 1. Or, again, thinking once around, the other angle that has a cotangent of negative 1 would be down here in quadrant 4. 45 degrees into that quadrant, 315 degrees. And then again, I could take this angle 315 and add 360, subtract 360. So I could add on to this any multiple of 360 degrees. So 360 degrees times k. Now, I could have consolidated this. Remember the period of cotangent, right? The period of the cotangent function was 180 degrees or pi radians. So I could have just stuck with the 135 and then just said add 180, then add 180, then add 180. You know, because if you add 180, you're at 315, right? So I could have consolidated this. You know, this is equivalent to, this goes in both directions. I could have said that theta is just equal to 135 degrees plus, you know, some integer multiple of 180 degrees. I could have done that, but again, that's only because it's cotangent. Right, cotangent and tangent are the only two of those functions that has a period of 180 degrees or a period of pi radians. All right, but I'll stick to this. All right, I'll stick to this. This is fine. This is like all the other ones I've shown you probably, you know, in my sine and cosine videos and stuff. All right, so there's a description of all the infinitely many solutions to this equation. And something else I like doing, again, you don't have to do it because, you know, they only asked you here for the solutions between 0 and 360. So that would be 135 degrees and 315 degrees. So you can stop now, but I like to list a bunch of solutions just to get a feel for them. So I'm going to list solutions. So, you know, just put in different integers for k here. So when k equals 0, when k equals 1, when k equals 2, when k equals -1, when k equals -2, and so on. Right? You could keep going if you wanted. Now when k equals 0, right, you got 135 degrees and 315 degrees, right, from these two. Now if I go along the top, you know, if I just use this top equation here, I'm just going to keep adding 360. Right, just keep adding 360. So if I had 360 degrees, that's 495, right? So when k equals 1, right, you're getting 495. If I add 360 again, that'd be 855. No. Yeah. Yeah, 855 degrees. So if theta were 855, replaced with 855 degrees, that would also be a solution. And again, you can keep going. Now if I subtract, now if I go this way when k is -1, you know, subtract 360, that'd be -225, right? And subtract another 360 when k equals -2, be -585, you know, and so on. Right? Again, I could get all sorts of solutions from this. And then do the same thing for the 315 line, right, with this second branch here. If I'm going this way, I'm just adding 360. So that'd be 600, you know, so I could replace theta with 675 degrees and it would make the equation true. Add another 360. Let's see, that'd be 900 plus 135. So 1035 degrees. You know, I could replace theta with 1035 degrees and it would make that true. You know, subtract 360, I'd get -45. Subtract another 360, it's -405, and so on. Again, I could do this all day long. And right now, you know, here I've just shown you 10 solutions to this equation. 10 values of theta that make it work. But they want this, right? We want the value of theta to be, you know, from 0 degrees to 360 degrees, but not including 360. So when you're looking at all these solutions, you know, the only ones that solve the equation and are also in this range here are 135 degrees and 315 degrees, right? All these are too big, all these are too small. All right, so back on my problem here. They asked to select all that apply, right? We said 135 and 315. Right. Wonderful. Yeah, but you see how very, very similar this was to solving like a linear equation in sine or a linear equation in cosine. Very, very similar, right? It's just it's cotangent. Ooh. Alright, so hopefully watching me do this, looking at the more instruction, looking at these answer explanations, hopefully all this stuff helps you out when you're doing these problems on your own. And thanks for watching.